Hello, welcome everyone. In this video, I'm also again going over the power rule of derivatives. This time I'm going to be using negative exponents for the variables. So let's see how that helps. How that works out. So the definition of a derivative and power rule is that you have an nth degree polynomial, and when you take the derivative of that nth degree polynomial, you bring that n to the front. It becomes a coefficient times x raised to the n minus 1, and you subtract 1 from the exponent. So if we have if we're taking a derivative of x to the n, okay, which is the nth degree polynomial function, we bring the n to the front just like this and subtract 1 from the n in the exponent, okay, just like that. And the other thing is when there is a constant multiplying with the function, so we're taking the derivative of c times f of x. Okay, so a constant is multiplying with the function. This is times the dot or this asterisk. So this becomes, when we take the derivative, we take the c out of the derivative, and then we have c times d over dx of f of x, which is equal to c times f prime of x. That's another notation we use to write our derivative f prime of x. Okay, so let's go ahead and do this one. So we have x to the negative second power, and we want to take the derivative of this function. So we want to take the derivative d over dx of x to the negative 2. Okay, so we don't have any constant multiplying with it, so we can just use this formula directly. So we take the negative 2, make it the coefficient x minus 2, and we subtract 1 from it. So it becomes negative 2 times x to the negative 2 minus negative 1 would be negative 3. If you want to simplify it further, it becomes negative 2 over x to the 3. Okay, whenever you have a negative exponent, you can switch its position. You can bring it, since it's in the numerator, you can bring it in denominator and make it positive. So these two are correct answers, both of these, this one and this one. Okay, this one we have 5x to the negative second power, so it's very similar to this one, but now we have a coefficient multiplying with it. So what do? We use this one right here. When we have a derivative, we take the derivative of a c times some function. We take the c out of it now. Okay, the constant out of the derivative, and we take the derivative of function after that. So if we want to take the derivative of this, d over dx of 5x to the negative second power, I'm going to take the 5 out, and then we're going to take the derivative of just what is left inside, which is just x to the negative second power. So we have 5 times, when we take the derivative of x to the negative 2, we apply the power rule. So this negative 2 becomes a coefficient times x to the negative 2 minus 1. So 5 times negative 2, we can simplify it in the next step, is negative 10. And this x to the negative 3, and to simplify it further, we can also change the location of x to the negative 3, bring it in denominator, and change the sign of the exponent. So we have negative 10 over x to the third power. Let's go ahead and do a few more examples. Okay, so here we have actually a function already. We have the variable in denominator, so we have a fraction function here. So what we do here is when we take the derivative of this, so I'm going to show you. So derivative, we want to take the derivative of 1 over x to the third power. Okay, so we know in the exponents, when we have something in denominator, if we bring it into the numerator, we change its exponent sign. So this one is in denominator is positive. If we want to take it in the numerator, it's going to become a negative sign. So that's the next step I'm going to do, d over dx. So I'm going to bring this x cubed in the numerator, and it's going to become x to the negative 3 times 1 is still there, this one. So let's simplify this further, d over dx. So x to the negative 3 times 1 is just x to the negative 3. We can omit 1. We don't need to write it. Now we want to take the derivative of this. So it would be power rule. So you take the exponent to the front, negative 3, and x to the negative 3, and we subtract 1 from it. So this becomes negative 3x to the negative 4. And now you can take this x to the negative 4 in denominator if you want to, and it will become negative 3x to the positive 4. So I'm just doing the basic manipulation of exponents right here. X to the negative 4 can be written as 1 over x to the 4, bringing it in denominator and changing the sign of your exponent. And similarly here we have this function. We want to take the derivative of 3 over x cubed. Okay, so now we have a coefficient. Let's take the coefficient out first, this 3 from the derivative. So 3 times d over dx of 1 over x cubed. Okay, the next thing I'm going to do is using the laws of exponents. 1 over x cubed is the same as x to the negative 3, where you can bring this denominator into a numerator and change the exponent sign. And next I'm going to take the derivative of this. Okay, alrighty. And then, when we take the derivative of this, you bring negative 3 as a coefficient, and x to the negative 3 minus 1, you subtract 1 from your exponent. Now you have 3 times negative 3 is negative 9, x to the negative 4, and now you can actually simplify it further. Negative 9 over x to the 4th. You can bring this exponent in the denominator since it's negative to make it positive. So these two answers are correct in either form. Okay, it's just you have to know that when you have x to the negative 3 is the same as 1 over x to the 3. So that those are, this is one of the laws of the exponents. Whenever you have something, you can always change the sign of the exponent by changing its location from numerator to denominator or denominator to numerator. All right. Hopefully this will help.